Something very complex is, how does gravity work in space? Today I will be answering that question. There's a universal law for gravity. Pretty much what this is one mass is attracted to another mass. So pretty much any two masses are attracted to each other. But the bigger the mass, the bigger the stronger the gravitational pull. The closer that two objects are to each other, the bigger the gravitational pull it has. For example, the sun's gravity, since it's the largest star and object in our solar system, keeps everything from the biggest planets such as Jupiter to the smallest planets such as Mercury in the orbit around it. That's why planets don't just suddenly leave the solar system. This is gravity in about the most simple terms. We live in a solar system, yet some people don't even know what it is and what it's all about. That's why I'm going to teach you about it today. We first start off with the sun. The sun supplies us with all of the heat in our solar system and is about 10,000 degrees Fahrenheit. After the sun is Mercury. Mercury is the smallest planet in the solar system and is just bigger than the moon. After Mercury is Venus, which is the second closest planet to the sun. Venus's days are longer than their years, which means that it takes them longer to rotate, for Venus to rotate in a circle, than it takes to orbit around the sun. After Venus is Earth. Earth is the only planet in this whole solar system that is known to have complex living organisms. After Earth is Mars. Mars has the color of red because of all the iron in its soil. After Mars is the asteroid belt. Some of the asteroids are hot and some are cold, depending on how close they are to the sun. After the asteroid belt is Jupiter. Jupiter is the biggest planet in the solar system and has 79 moons. After Jupiter is Saturn. Saturn is known for its 7 rings, so you probably know that. After Saturn is Uranus. Uranus is the coldest planet in the whole entire solar system, despite being the second farthest planet away. It once reached temperatures as low as negative 371 degrees Fahrenheit. Neptune is also a very cold planet, about negative 25 degrees Fahrenheit on an average day. And finally, Pluto, founded in 1930, but sadly became a dwarf planet in 2006. If you look at this image of the seasons, you can see that both winter and summer are farther away from the sun, but fall or autumn and spring are closer to the sun. Sadly, a lot of people do not know the answer to why this is, but luckily for you, today I will be explaining all of this to you. Now that we've got all of that out of the way, cue the intro. The answer to why is actually really simple. It's all about the sun's rays. So in December, the sun's rays are the least direct at the northern hemisphere, causing it to be colder. There is a solstice in the winter. The December solstice is when the sun travels the shortest path through the sky. After this is spring, when the sun's rays are not as direct to the northern hemisphere, but they are kind of direct. There's a spring equinox. During the spring equinox, the Earth's axis and its orbit line up so that both hemispheres get an equal amount of sunlight. After spring is summer, which is where the sun's rays are super direct towards the northern hemisphere, causing it to be the hottest season. During the summer solstice, it is the longest day and shortest night. Then finally there's fall. During this, the sun's rays are similar to spring's rays, but not as direct. There is a fall equinox. During the fall equinox, this marks the precise moment when the sun appears directly over the Earth's equator. There are 8 different phases of the moon, and today you will learn about all of them. Before I get started, I would like to say that the reason that we see different moons depends on the sun's reflection to the moon. Now that we've got all that out of the way, cue the intro. We first start off with the new moon. The new moon is when we can see absolutely no moon. This is because no light reflects off of the moon. Next is the waxing crescent. The waxing crescent is when about 25% of the moon is lit up, and it's in like a crescent shape. After the waxing crescent is the first quarter. The first quarter is when half of the moon is lit up on the right side, but it only increases from here. After the first quarter is the waxing gibbous. The waxing gibbous is when 3/4 of the moon is fully lit up. And finally, after this is the full moon. The full moon is when the whole moon is fully lit up. But sadly, because waxing means increasing after the full moon, we get waning, which means like decreasing. So, next is the waning gibbous. The waning gibbous is also 3/4 of the moon lit up, but this time instead of going up, it decreases. So after the waning gibbous is the third quarter. The third quarter is half of the moon lit up, but this time on the left side. And finally, the waning crescent, which is 25% of the moon lit up on the left side. Now you know the phases of the moon. This is a solar eclipse, and this is a lunar eclipse. They happen about once or twice a year, but knowing this, it's crazy to know how many people don't know what a solar or lunar eclipse are. Luckily, it's really simple. Now that we've got all that out of the way, cue the intro. Solar eclipses are complex but also simple. The reason that they happen is when the moon gets in the path of both the sun and the earth, casting a huge shadow. There are these two things called the penumbra and the umbra. When the moon is in the penumbra, the shadow isn't as much. Likewise, we don't see, or it doesn't become as dark. But when it gets in the umbra, this casts a very big shadow, and we see, and it becomes very dark. The reason that this happens is, despite the sun being 400 times bigger than the moon is 400 times away from the sun, making it seem like they're the same size. A lunar eclipse is between 30 minutes and maybe over an hour. The sun sends out wavelengths of colors. Shorter wavelengths are colors like blue, but longer wavelengths are colors such as red. Sometimes when the moon is going in its path, the light can hit the moon, causing it to be red because the wavelengths are longer. Eventually, the moon will just keep on going in its path, and the blood moon or the lunar eclipse will eventually stop. Now you know what a solar and lunar eclipse are.